Sonic, the heart of your system.
Hi and welcome to the second part of the $200 AliExpress DIY chiller. As you have probably seen in the previous video, this thing does not work. So the problem is, or the original idea was that we are spending $200 on AliExpress tech units. So we have aluminum cooling blocks on the bottom, which are chilled or cooled by a Peltier element or a tech, which is sitting in between here. And then we have an aluminum finned heatsink on top with those small 40mm fans. But the issue is that the power consumption of the tech is something like 40 or 50 watt. Therefore, the heat dissipation is the same, and the aluminum finned heatsink is really not capable of removing this amount of heat. So we have to replace those heat sinks with something else. And the solution is kind of obvious and also very simple. We will just add another water cooling loop on top to cool the techs. And for that I have those copper cooling blocks. Obviously a lot of people commented that it would make a lot of sense, and cooling performance wise it would be better to use something like an EK block. Obviously I totally agree with you guys that if we would put 12 EK blocks on here, the cooling for the techs would be massive. But then investing like, I don't know, 600-700 euro just for the cooling blocks wouldn't really make that much sense. So I bought those instead. I think I spent about $8 per piece, and those are copper cooling blocks. I bought 24 in total. So we will replace not only the aluminum finned heat sinks, but also the aluminum heat sinks which are sitting on the bottom, which are essentially cooled or chilled by the techs. So we will replace both, basically creating a sandwich of two of them and having the tech in between. It's a shame how much thermal paste is wasted for this, because I think we, I don't know, put on 20 grams of Cryonaut and now I have to replace it. What a shame. Two of the sandwiches are already mounted on here, and I'm just about to assemble the third one. If you take a look or a closer look at the copper heat sinks, you can see that one surface area or surface quality is kind of, yeah, it's, I'm not sure, it's like hand sanded, and the other side is CNC milled, so that one feels really, really smooth. That's the side we will use for either hot side or cold side of the tech. So this goes just on here like this. Then of course we need a little bit of Cryonaut. We will not use as much as before. I think I overdid it last time a little bit. I have to make sure that the cold side is facing down. Ah, nice. Thermal paste all over again. So again, thermal paste for the hot side. Put the second copper piece on top. Put on the heatsink. Fix everything with two small M3 screws. I don't really have to use this, obviously, because yeah, doesn't really make much sense to use the aluminum finned heatsink for this on the top, but otherwise I would have to use some kind of adapter or just a plate on top to apply the pressure onto the sandwich. And I think this is just easier, and if we can dissipate, I don't know, like 1 or 2 watt with this piece on top in addition, certainly doesn't hurt. So I have to repeat this 9 more times and then we're done. As you can see, I'm done with the sandwiches and I'm in the middle of the tubing. This is a different tube than last time. This is the one from last time. It's a PUR tube, so it's a little bit soft. As you can see, and this one is an Innovatec tube, not really sure, I think it's PVC. So it's not as soft, and I think it's better for making this leak proof. So I'm just connecting all the blocks on the bottom, and afterwards I will connect all the blocks on top. Once I'm done with that, once all the cooling loops are established, I'm also going to mount this DDC on the plate. I already drilled the holes for it. This DDC will be for the cold loop, so basically the loop that's going to be connected to external radiators. And then we still have the second DDC, the smaller one, which we will then use for the other loop. On my table I now have two EK Coolstream PE radiators, 2x480. They're already connected with each other. We have some distancers on the bottom, which are mainly to keep space between the radiators and the table. So we will put the EK fans on top here, 8 in total, and we will essentially connect the tech plate on top of it later. So I'm trying to save a little bit of space. I first thought to put the radiators and the pump next to it, but it really takes up so much space, so I decided to come up with some kind of sandwich design. So radiators on the bottom, then fans on top, and then I somehow have to connect the fans, I guess also with some distancers again, with the tech plate on top, and then it should be done. As you can see, everything is up and running. We filled the top, the hot cooling loop with blue fluid, so that's the loop that's actually cooling the techs. We had some trouble with the older tube, with the softer tube. We used it for connecting the input and output of the copper blocks, but I think the copper blocks have like 1 millimeter less radius or diameter for the connectors, and therefore they were leaking, so we had to replace all the soft tubes with the PVC tubes from Innovatec. Now everything is up and running, looks good. As I said before, top loop is filled with the blue fluid and the cold loop is just filled with distilled water at the moment. That's mainly because I'm not sure if the chiller works and what the performance will look like, because if the performance is really solid, maybe we can hit like 0 degrees Celsius, which means that we need some kind of fluid that will not freeze at 0 degrees Celsius, so that could be that we have to replace the fluid later. That's why I just used distilled water for now. The fans are already running, so the only thing missing is power for the techs. I will now connect the techs to the PSU and we will just keep it running for 15 minutes and check back what the temperature will look like afterwards. And before I forget about it, a lot of comments stated in the previous video that the speed of the fluid will be important, and some people said that it has to flow really slow, because then in the end, once it exits the loop of the techs, it will be very cold, the fluid, but then we have the problem that if it's flowing too slow, we cannot remove the heat from the CPU block anymore in the end, so we need fluid speed. It has to be a decent flow rate, otherwise we will not be able to cool the CPU. It will look nicer at the beginning because it feels like the water is colder once the flow rate is really low, but we need a higher flow rate for cooling the CPU in the end, so that's why we're going for DDCs, and DDCs have a lot of power. You can probably hear it, you can also see it, everything is up and running and it really works. So we have a room temperature currently of 25 degrees Celsius. It's really warm in my room currently. It's also 2 a.m. in the morning, so still working on this. And you can see the cooler base temperature is 12 degrees Celsius. So we are 13 degrees Celsius below room temperature. So the chiller works. It's not as good as I expected. I hoped for something close to maybe 0 degrees Celsius, but it's actually working and I'm really happy about that for now. Currently we don't have load on the CPU cooler. The CPU cooler is just sitting on the table right now. We have condensation already on it because it's so low in temperature, 12 degrees, that condensation is already building up, but we know that it works. In the next video we will test what we can do with this. So we will attach it to, I don't know, 9900K, maybe a Ryzen CPU. Maybe you have a special wish what you want to have tested. Let me just know in the comments what kind of hardware I should test with the chiller. Maybe you have another idea what we can do with it, what we can test with it, and also if you have more ideas maybe to improve it, because currently right now I think we're pretty much on the limit with this cooling construction. Let me know in the comments what you think about it. See you soon.